Alright guys, welcome back, and today we're going to go over 2.6, which is quadratics with complex solutions. And this should be pretty quick because we all just did a lesson on imaginary numbers. And so this is basically that, except we're just going to be combining that with solving quadratics, which is what we've already been doing. And for warm-up, I have recalled the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a, and it seems like a whole lot of a whole lot of stuff to say, but once you use it a couple times, you kind of just remember it. And so real quick, here's like a recall slide of the quadratic formula. Remember, very important, we need to have equals 0, right? Because the quadratic formula really pulls off of that zero product property we talked about. That's where it really kind of comes from. So you do need that equals 0. And then just a quick reminder on imaginary numbers, the square root of -1 is I. So if you square that, takes the square root away, -1. And then you cube it, so -1 times I is just going to be -I. And then again, I to the fourth would be I squared times I squared, or -1 times -1, which is +1. So quick reminder, if you don't have this stuff written down, at this point, I would definitely write it down. But we're just going to get straight into some examples. So what are the roots of the equation x squared plus 10x plus 41 equals 0? Well, when I hear roots, I'm basically thinking solutions, x-intercepts, right? So, your first instinct with these might be to factor, but I just know in this section we're not going to, right? But if you tried to find multiples of 41 that add to 10 to factor this, you just couldn't do it. So what we have to do is we have to use the quadratic formula. And remember, so I'm going to write this out. A equals, there's an invisible 1 there. B equals 10 and C equals 41. They're all positive, right? And we have equals 0, so we're good to use it. So negative b, -10, plus or minus the square root of b squared. I'll write it out, 10 squared minus 4 times a, which is 1, times c, which is 41, all over 2 times a, and I'll write this one all the way out. And this is going to be x equals -10 plus or minus. We can do 10 squared is 100. So 100 minus 4 times 41 is going to be 164. All over 2 times 1 is just 2. And let's just keep working on this. So then x equals -10 plus or minus the square root of -64 all over 2. And hopefully we're comfortable with this by now. It'll be -10 plus or minus, and then we take an I out, and then we have the square root of 64 all over 2. And then we have x equals -10 plus or minus. The square root of 64 is 8, so we really have 8i all over 2. And then we can divide both of those things. Then we have negative 10 divided by 2, right, is -5. And then we're going to have plus or minus 8 divided by 2, which is 4i. So you just do them both, right? Because that's the same thing as -10 over 2 plus or minus 8i over 2, right? Because we were just add or subtract across, so we can just divide. So that is your answer, and Delta Math will have this nice little plus or minus thing for you that you can hit. But yep, 2 answers, right? Plus or minus, because whenever we take a square root, we're gonna have 2 answers. And it makes sense that when we're dealing with a quadratic, we have something squared, we're gonna have two roots. So next one, we have a equals 9, b equals 42, and C equals 50. And let's just start writing it out, right? Negative B, I'm going to write x equals negative B plus or minus the square root of B squared. Gotta wait for my screen to turn back on. Minus 4 times A times C all over 2 times A. And I'm going to simplify this one a little faster. Negative 42 plus or minus the square root of 42 squared minus 4 times 9 times 50. It's going to be negative 36 all over 18. And guys, this is just algebra working with imaginary numbers, which we just did. So really, it's kind of just more practice with imaginary numbers. Negative 42 plus or minus. We would take an I out, and then the square root of 36 is 6. So really, we have 6I all over 18. And then we can split that up to negative 42 divided by 18 plus or minus 6I divided by 18. And we can do 42 and 18 can both be divided by 6. So that'll be 7, negative 7 all over 3, and then plus or minus 6 and 18 with a 3 on the bottom, I over 3. Or if you want, it might be nicer to write it as 1/3 I. Right, because there's an invisible one on the top, and you can just throw that I out front. I think that might look nicer. You might want 1/3 I. And then this one, what did we put? Yeah, we already had that in a nice A plus BI. That way the I is kind of like separate, right? That way your B is 1/3. Now, last one. What are the roots of the equation? I'm just going to A equals 2. Start writing these. B equals negative 15. Oh, but before I do that, what do we notice here? We need equals 0, don't we? So let's add 32 over. Right, so I'm actually going to have 2x squared minus 15x plus 32. And then this is the important part. This is what we wanted. We wanted equals 0. Right? And now we can do it, right? Now we have A equals 2, B equals negative 15. The negative matters. C equals 32. So now we have negative B, negative B, which is negative 15 or positive 15, plus or minus B squared. So negative 15 squared minus 4 times A times C all over 2 times A, which is 2. $15 plus or minus, and then here we'll have square root of negative 31 all over 4, and then 31, or let's just continue to write this. We have x equals 15, and then we can pull out an I on the square root of 31, right, all over 4. And now, I don't think 31 breaks up nicely into anything, right? So we're kind of just left with that. And what we do now is we would normally split this up, right? We'd have 15 over 4, which doesn't split up nicely, plus or minus. Then we could write square root of 31 all over 4I, right? And that's just how we're going to have to leave it because none of this simplifies. So this is actually our answer. And that's going to wrap it up for 2.6.